We all know the cloud-native code, right? Everyone knows the cloud-native code. We refactor our applications as microservices.
This is the way.
We package those microservices in containers.
This is the way.
This is the way, folks.
I get it.
We orchestrate those containers with Kubernetes.
This is the way.
We deploy to the cloud.
This is the way.
We believe in declarative config.
This is the way.
Servers are cattle, not pets.
This is the way.
Our deployments auto-scale.
This is the way.
We build our apps on open source.
Amen. This is the way.
And we optimize our architecture after receiving a bill that gets the CFO rather upset.
This is the way. Always.
So, these truths we hold to be self-evident. But it wasn't always the way.
Yeah.
Sorry.
No problem. So, this wasn't always this way. Back in the dim reaches of time, like 10 years ago, there were other technologies out there. Technologies that we used before Docker, before containers, before everything Kubernetes, before all the things that we love, or at least love to loathe in the landscape that some people are now maintaining here in this room. In retrospect, this is, that we now look at those things, in retrospect, we look at and say, those are the things that actually got us here. And this is not uncommon. Technology is always evolving. And in fact, empires are always built on the foundations of the things that came before.
Yeah, and if we think about how do these technologies that we now take for granted, how did they go from being an early innovation through to being mainstream? You've probably seen this chart before. There are innovators who take these early ideas, then there are early adopters, and then there's this chasm that you have to cross when you want to get a technology to be adopted by the majority of the market. And I think we can say today pretty confidently that Kubernetes, I think, is in that mainstream market. Pretty much every enterprise out there is adopting it in some way or another. But if we're going to look and see, well, what comes next, we need to look to what's in that left-hand side of the chart right now, or what might be coming there that hasn't yet crossed the chasm. But to do that, I'd actually like to just take a few minutes to go and look at how we got to where we are today, because I think there are some things where we can start to draw lines going forward. So when we think about innovations, it's actually, they often get categorized in a couple of different ways. So they're often considered either to be a sustaining innovation, and in this case, this is something where you've got an existing product, an existing market, and you're just making improvements to it, but it doesn't fundamentally change the market structure. Now, it can be very innovative, and everyone wants to call their thing disruptive, but a lot of innovations, most innovations, are actually sustaining ones in an existing market. And then you have things which are truly disruptive, where you have something like an iPod comes in and completely changes the way the way we consume music, and completely changes the market. And that can either happen by a product coming in at the low end and disrupting with kind of a very, very low cost alternative, but maybe simpler, or it can come by the creation of an entirely new market. So when we think about what's next, what's going to redefine the way we're all working in a decade's time, we're really thinking about what are these disruptive changes that are going to be happening to the market.
So, next, let's form more. I added a slide and didn't get put in the build. There we go. I had one object. So let's think a little bit on the road to cloud native. So actually, we go back a little ways. We go back into the 1980s and the 1990s. So think about this, the PCs, the evolution of Sun, Java, Linux. I actually threw in there a little event that wasn't actually a technology as much as a decision. And this was, the lead to, democratization of compute in the IBM PC, the democratization of Unix, or the Unix design pattern, Linux, Sun, and what happened with Sun, the decisions that NSF made that opened the doors of the internet to the unwashed masses, took it out of the research world, and that opened up for Netscape and eventually Windows 95 and Internet Explorer, that really started us down this road. Made Sun a lot of money, by the way, when all of that happened, because pretty much everything was running on Sun by that point. We get into 2000s, and we start seeing things like jails and Solaris zones, which are the first attempts, very early attempts at containerization and isolation of workloads. I'm a BSD guy from way back, so I had to put that in there. I'm sorry. Early virtualization from VMware, and then the open source evolution of that with KVM and Zen. So we now start seeing virtualization starting to come on board, and then open source virtualization coming soon thereafter. So we have a commercial coming in, starting to now take on the server market and virtualizing it, and then open source coming along. And finally, we now see people putting that together. The internet starting to be ubiquitous connectivity, the RESTful APIs that came along with that, the open source and virtualization, and that leads to IaaS. First commercial, then open source in OpenStack, CloudStack, obviously AWS CC2 predecessor to that, and we start seeing PaaSes starting to come along. First, again, Heroku, etc., then things like Cloud Foundry, open source PaaSes. So all of these things that are now setting the stage for what we call cloud native design patterns are all set, and you can see the path that we took to get there. The innovations, all of these things were disruptive changes to the market over a period of about 20 years to set the stage for what Andy's going to talk about next.
Yeah, so by about 2013, so 10 years ago now, which is a long time in technology, you see the outlines of cloud native as we know it today starting to form. So you have the foundations being built with Docker, with CoreOS, which a lot of people know for the operating system, but another big thing that they introduced was etcd, which became the foundation of the distributed state store that drives Kubernetes. So very important in the foundations. And then you had the orchestration and ultimately creation of the CNCF, which really made a lot of what we're going to talk about today possible because it created this independent, neutral governance and home for a lot of these projects. And then there's kind of, I think of it as kind of two phases. There's that foundation of cloud native, where we really worked out what does cloud native mean, and then you had the maturation. And a lot of what we've seen since 2015, so over the last 7-8 years, has really been filling out of a lot of the ecosystem around that original idea. So in that sense, most of these things are not necessarily disruptive. Most of these things are actually sustaining technologies. But I'll talk about some of them a little bit later, because I think some of these do have really important impact as we think about the evolution going forward.
So let's talk about this. Test for you all. Is this A, an incredibly rich and impressive ecosystem? B, a terrifying array of options for a cloud-native newcomer? C, a tar pit for VC investment? Or D, all of the above?
I'm glad you made the co-maintainer of the CNCF landscape laugh at that one.
Yes, exactly. Today, this ecosystem has blossomed to an extent that we could not have believed just a few years ago when we started this journey. The point where it's become an impossible challenge for anyone to know or build a technology stack There are so many projects to choose from. However, and a big nod to Chris. She unfortunately can't be here to talk about this today herself. But we shouldn't lose the sight that that's all up there because Kubernetes is there to build problems. It's built by people to solve people's problems. And it's an indicator, it's there to solve people's use cases. People are bringing their use cases to Kubernetes because it's here and it can do that. And this is what happens when you have a mature market. This is a reflection of the maturity and breadth and adoption of Kubernetes. This is the sign of this design pattern and Kubernetes and the CNCF, or the cloud native design pattern, success. People are bringing the problems, and that triggers the ecosystem we see today. That has its good and its bad side effects, but it is a sign of why we're all here.
So Gartner has this thing called the hype cycle. Has everyone seen a hype cycle curve and how they talk about evolution of a market? So this is their curve for cloud technologies. And so if you listen to Gartner, they say we're at the peak of inflated expectations for cloud native right now. And we're about to go through the trough of disillusionment. And I don't know, personally, I feel like I went through a trough of disillusionment and came out the other side a while back. But I think I would question where they put cloud native there, but
not the first time I questioned Gartner, but yes.
The interesting thing is not so much kind of where it is on the curve as the fact that they have the color coding of this puts a 5 to 10 year life cycle on cloud native between now and when the technology plateaus, as they call it. So that's kind of an interesting way to think about, what is the runway left for cloud native.
Actually, Andy, the other interesting thing is they show generative AI only having a plateau of 2 to 5 years, but cloud native having 5 to 10, which is an interesting point off of this slide.
So as we look at the things coming, I'm going to talk about 3 main themes. I'm going to talk about, yes, I work for Microsoft. I'm going to talk about artificial intelligence. I think it's in our contract that we have to. I'm also going to talk about something I'm going to call pervasive cloud, for want of a better term right now, but it's a term I've seen used. I think it describes quite well what we're getting at. And I want to talk about developer experience as the third of these kind of 3 themes.
Since I work for Cisco and pervasive cloud requires network, therefore I get to stamp my passport too. And since you need a network to get to pervasive cloud, therefore, boom, I've paid my paycheck too. So We're all good.
So let's talk about AI, because I think there's been a lot of discussion about AI. I don't know, some of you may have seen some of these numbers, but there've been some studies around the impact of productivity of just of GitHub Copilot. And if you think about, there are many potential applications just on the application of programming, right? What kind of an impact does that have on an industry? Right, and you can see the numbers here. It's 55% more productivity, $1.5 trillion of GDP impact. These are not small numbers, right? This is massive when you think about what that effectively creates in terms of additional programming and technology resources. Because if now I can get, if everyone's producing twice as much, that effectively doubles my number of developers overnight if people are starting to use this technology. To put that into some kind of comparison, compared to the impact of the steam engine, right? That had an impact of 0.3% per year over, the few decades of the Industrial Revolution. Yes, if you apply that to the global GDP, that's quite a lot of. That would be quite a lot as well. My point is, this is a similar kind of scale of change. We are unleashing a new industrial revolution, and that is going to have massive impacts on us. And I'll come and talk about some of those. It's not only productivity. Interestingly, it's actually people's satisfaction with their job when they're using these AI tools increases. So people are less frustrated when coding because they're doing less mundane tasks. They're more fulfilled. they're just more satisfied. They manage to stay in flow because they don't have to jump out of the flow to go look up trivial things. The Copilot just finds those things for them. And I thought this, there's a quote here from a developer, I have to think less. When I have to think, it's the fun stuff. So I think, from our perspective, we're often focused, particularly when we're operating Kubernetes clusters, on some of the challenges of the day. These kind of things can actually make our lives better. What about cloud native? I mean, clearly all of that impacting developers, that's part of the cloud native ecosystem. So that's already a huge impact. But how else do you impact cloud native? So the first, I would say, is obviously if you're running Kubernetes clusters, if you're running clusters, depending on the kind of environment you're in, you are likely to see demand from your users for running AI workloads. Whether that's training models or just applying them, and particularly, say, if you're running on-prem workloads, how am I going to get the GPUs for that? So it's actually going to drive demand, and this is going to be something that you need to plan for. But it's also going to enable new applications. So the applications that we're running in these clusters, powered by AI, are going to be able to be more innovative, and you're going to be businesses are going to be driven to deploy AI enablement in their applications purely from a competitive standpoint. We've been Microsoft been working with one of the large car companies and putting AI-enabled services in cars, and that's just the beginning. Everywhere, it's going to be everywhere. The same things that I talked about that apply to developers are going to apply to operators as well. So if you need help while you're in the middle of debugging some problem with a cluster or configuring a cluster, there should be a Copilot there to help you with that. And that should improve satisfaction in the same way it does for developers. The other thing which I think is interesting, and we haven't really started to see yet, is when you actually apply AI to the operation of your clusters. Can an AI model predict better when to scale up your cluster? Can it predict better when you're going to have failures? Can it predict better where you're going to need bandwidth between various nodes in the network? And those kind of real-time optimization decisions could actually increase our efficiency of operation as well. So I do think AI is going to be a big deal. I know I'm paid to say that, but it is. it actually is something I think. I'm going to do a demo here, but I have a video which cannot be loaded. So that is excellent. It says video cannot be loaded.
Are you connected to the Wi-Fi?
Yes, I am connected to the Wi-Fi.
Just reload it.
Okay. Okay. Well, I will. Maybe we'll come back to that.
Okay.
Because I'm not sure. I don't want to break this. But what I'm going to show is there's a couple of references to some GitHub repos here. So there's one thing I was going to show is kubectl AI, and you can go try these. So basically, you do kubectl AI, and then in quotes, in a natural language format, whatever it is you want it to do, and then kube Copilot, which will go and inspect your cluster and give you hints on, look at your logs and tell you what might be going wrong and those kind of things. It's pretty cool. So we'll move on.
We will move on. Exactly. Okay, so now I'm going to be the buzzkill to all that wonderful stuff. So one of the things I do at Cisco, I own all things Kubernetes in the data center infrastructure, and I also own all things sustainability. So I've been having lots of interesting conversations with lots of big customers around sustainability and infrastructure, et cetera. So I'm going to have some cautions around AI. One, and the chant we just did, deploy everywhere, platform agnostic, et cetera. CUDA. One of the things we have, and this has been come up very especially around power demands, especially around certain platforms that are used for AI, And there are other platforms that potentially have better power performance, et cetera, that are out there. And you start talking to customers about said platforms. And they say, oh, that would be wonderful, except my code only runs on CUDA. So therefore, we have to use said platform. We can't use anything else. And oh, by the way, it takes us many, many months to get those GPUs, and I'm sure none of you know who I am talking about. I'm not mentioning any names. However, that is a problem, right? So as long as we are in that boat, we are sort of in a software monoculture. So we've talked about how cloud native allows us to be sort of platform agnostic, and we can write stuff once and deploy it across many different platforms. This is one case where we can deploy on many different platforms, sort of like the Ford thing. You can have your car in any color as long as it's black. You can deploy your workloads on any platform so long as it runs CUDA. Right now, that seems to be the case. So that is one caution that we need to keep in mind right now. Sure, we can fix that, but we need, as an industry, to have the will to do so. So that is one caution. 2, we all also now, hopefully everyone here, how many people, raise test here, how many people work for a company that have some kind of ESG goals to be carbon neutral by some period of time, or reduce power, be more power efficient by some period of time? Good set of hands, etc. Excellent. You do realize that most folks, when they start looking at this, are looking at a power increase of about 1 to 2 orders of magnitude per rack within the next couple of years in order to make the AI infrastructure work. But at the same time, they want to reduce carbon input. This does present a bit of a problem. So we need to figure out how to get much lower, either make the power that we bring in much lower carbon impact, or reduce the amount of power coming into the data center by being more efficient in cooling or other things, etc. Not saying we don't do this, but we have to think about the impacts either on what and we can't just, by the way, foist this off on the Microsofts or the Googles or whoever else is the public cloud, because unless you understand the way carbon accounting works, just because you give it to somebody else, you still have to account for it in your carbon accounting, because you're still requiring the work to be done. You just can't hand it off to someone else. You still have to account for the carbon emissions.
It's okay, just put it in Azure, we'll take care of it for you.
So, this is just some of the things to think about. This is all wonderful things. There is impacts to this. And this is something we're going to have to think about as a community as well. We have to be able to monitor this and measure this and figure out the impacts and figure out how to try and minimize this impact as much as possible going forward.
Yep. Good points. We'll talk about pervasive cloud now, because I think one of the maybe unspoken assumptions around cloud native is there's this big computer in the sky that we just throw workloads to, and it's infinitely scalable, and it doesn't really matter where it is. I mean, yes, we think about, do we want to be in US East 1, or do we want to be in, a European data center? But like, other than that kind of continental level location, we don't really think about location much. We don't really think about limits on the number of VMs we can create. It's a big, giant thing, and a lot of the cloud-native architectures have been built around that. This is changing. It's changing for a number of reasons. One of them is just geopolitics, right? With a kind of a deglobalization trend, you're seeing more and more sovereign clouds and more nation states saying, hey, we want to make sure all the data stays within our borders. You're seeing regional clouds, and that's not just a sovereign cloud kind of thing. That's also because there are applications which are more and more latency sensitive, and therefore you want workloads to be closer to the end user. We've got space applications. There's a thing called Azure Space. It's people are deploying applications to space, and that's part of the cloud of the future. There are industry-specific clouds. You'll have clouds built for telcos. You'll have clouds built for industrials. People are familiar with edge and IoT. That's moving workloads out to the edge. On premises, definitely it's going to be a part of the mix as well. We have, for example, ways that we can tie on-premises workloads into cloud now and make those VMs on your on-premise rack look just like they're part of the cloud. And of course, we still have the traditional public cloud as well. So the locality of workloads changes and starts to become something that is relevant as you're thinking about the architecture of what you're deploying. And in particular, what this really means is you now have to think about, you have a heterogeneous compute environment. You can't necessarily assume that where I put a workload here, that's the same as a workload that I put somewhere else, right? So you're going to have different architectures. We already see, with ARM64 in the cloud. I don't know, has anyone tried to deploy to ARM64 and found that their favorite application, like the container, wasn't available as an ARM64 build? Yeah, it's happened to quite a few people, right? Just because you've got a container doesn't mean I can now deploy it into a Graviton or machine, right? So we want a true run anywhere kind of capability for code, and that's in the original Java sense of the term, not the Docker sense, right? We're going to have workloads that are more loosely coupled. We can't assume that we have high performant, highly available networks between all workloads at all time. We're going to have constrained environments, RAM, CPU, et cetera, are going to be constrained in some of these edge devices. And because data is going to be dispersed, we're going to want to have functions dispersed where that data is in some cases. In some cases, we're going to want it in other places. And the upshot here is this isn't the cloud that we built cloud native on, right? We think the declarative model, now that's one of the things that we've built that'll probably stay. Probably still the Kubernetes API even. It's a good generic API for telling a control plane what it is you want. That the controller model of reconciling actual to desired state, I think is a good one for this world. But a lot of those assumptions change, and either we have to get smarter or the layer below the API has to get smarter in order to cope with that.
And one thing to keep in mind as well, as we now have more constraints as well, again, ESG goals, not just cost. There are now going to be more things your executives are going to get excited about on their monthly report. Are we now going to be willing to have our workloads relocated partway through a long run because all of a sudden some data center went from 100% green to being coal-fired, for example? Or are we not going to be happy with that? Or any of the other things that might be driving us other than just cost? It's no longer going to be just a one or two dimensional thing about placement. It's going to be multi-dimensional going forward.
So the next thing that kind of comes out of this is the unit of code deployment. We have went from deploying packages on individual pet servers to deploying VM images, kind of appliances in the cloud, to containers. And this is likely to evolve for all those reasons I just talked about. And I'm going to put it to you that in this world, we're going to see a lot more WASM, otherwise known as WebAssembly. It's still pretty, I mentioned it in the chart earlier, so it's been around for a little while, but it's still pretty early in terms of its development, in terms of getting to be usable in the way that Docker containers were. But even Docker now has added support for WASM, so you can use Docker to deploy WASM modules. You can store WASM modules in an OCI registry. And I think this really starts to become an additional way of deploying code. And it's worth pointing out these older things haven't gone away. I mean, people still have package managers, people still deploy VMs, but it's kind of going to be the next model. And if you don't believe me, then this quote is from Solomon Hykes, who is the guy who came up with Docker, right? Saying, if we had WASM when we started Docker, we wouldn't have needed to have created Docker. That's how important it is. So if you haven't checked it out and thought about it, and you're interested in what's coming, I do recommend you check out what's happening in the WASM ecosystem.
Yeah.
The last point we're going to talk about is the developer experience. and modernizing software development, which is really key. I'm just going to touch on a few quick points here. Right, so the first is serverless. With serverless actually not massively adopted yet, but these numbers are from Gartner, by the way, so their forecasts, take them with the Gartner pinch of salt. But it's going to be a significant way of how applications are built and deployed. Developer portals, and this is super important. The developer experience, we're seeing the whole concept of developer portals becoming much more critical part of how people think about their platforms. How we develop, we were just talking about this earlier, like the whole world of a laptop or a developer workstation, which is completely separate from the cloud and its own dedicated environment, that's going to change. We're going to have the same kind of impact on the developer environment coming from things like browser-based IDEs that we had from moving to the cloud in the first place. Security. You've probably heard 100 talks on security. I'm not going to go into depth, but it is something which will have to become much more central to how we build, develop, deploy, manage software over the next 10 years. Telemetry, a lot of talk about open telemetry. That's really going to, standardizing the telemetry layer really changes the game and will increase the level of instrumentation, level of visibility you get into code, not just through the OpenTelemetry protocol, but also through things like eBPF, which allow you to deploy code into the kernel and monitor what things are going on. And then the last thing is the low code and no code. So the key thing here is that you're going to have a lot of apps built in the enterprise or in large organizations, not by software developers anymore, but by line of business experts. They're not really developers, but they can point and click a bit, and that's going to be where the apps come from. And they're going to need to integrate into this environment where you're deploying more traditional containers.
And actually one that's sort of interesting, I would not call network engineers, classical network engineers, as in CLI jockeys, the world's most up to speed on cloud native. I say that in the most loving terms possible because they pay my paycheck. But I'm having conversations with 50-year-old graybeard Cisco CCIE jockeys about CI/CD and GitOps. And the first time I started having those conversations with those folks, I was like, did I just hear you right? And they say, yeah, how do we start doing that for managing our switches? And I'm like, okay, I'd love to have this conversation. I didn't think I'd ever have this conversation, but yeah, let's sit down and have this conversation. So this is moving from our community out in the organization into places that we would not expect to hear it. So it is already propagating.
So I'm just giving a shout out here to the Backstage project, which if you've not seen developer portals, check it out. It's a CNCF project. It's just a great example of the kind of direction that the developer experience is going to go in. So really, that wraps up some thoughts about where things are going to go. I don't have the magic answer. This wasn't a hidden announcement about the project that's going to change the world. It was more what are some of the trends and things that are changing? And I think we're going to see, a more automated, hopefully more fun, and productive developer and operator experience enabled and driven by AI and deployed in heterogeneous environments, which is going to start to become a much bigger kind of consideration. And hopefully AI can maybe even help us cope with some of these changes by optimizing networks and workload deployment placement and things like that.
So now we get to figure out what they're going to name this whole thing. Pervasive AI-driven cloud with WASM functions. I don't know. That's sort of klutzy. What are we going to name this thing? What are we going to have? Are we going to have this? Is this going to be sort of an AI-driven infrastructure, sort of like automated driving? Somewhere between level 0, it's going to help you park your car, to level 5, you can be reading a book or watching a movie while AI is just going to write and deploy your applications. You don't have to do anything other than check it every couple of months. Somewhere in between, where are we going? And whatever we think it's going to go, we're probably going to be very, very wrong over the next 5 years. So with that, what I suggest we open up for some questions, and maybe Andy gets another browser up to show the demo in the background if you want to try, if anyone wants to stay and listen.
Out of time. I think we're out of time, right, Flora? Yeah? Questions?
We are kind of out of time.
Okay.
But we have a whole after party where you can grab these two wonderful people, I hope.
Of course, we'll be there.
And ask all of your questions. And before we move out, I'm not your mom, but I'm someone's mom. So if you go out there and you have an alcoholic beverage, make sure that you also drink water next to it. Like, that's just a tip so that you can all show up here tomorrow refreshed and awake. I'd love for us to give it up for Andrew and Christopher one more time. And see you at the after party.
I have one more thing I wanted to say. So
Yes. Your next slide. Hold on.
No, wait. So I did want to say, going through this, all these kind of ideas are things that I would have, you probably saw what Chris mentioned. Chris Nova passed away recently. I mean, this is the conversation I would have had with her. She is the person I would have called, and we did, and we had a lot of chats. And so, so I wanted to dedicate the presentation to her, and I think she'd have had a blast with this. So.